Now, when we talk about cell potential, first and foremost, what is cell? The cell we are referring to is not the cell in biology, right? It is a cell in chemistry which is known as electrochemical cell. So first, I'll say the cell here is the electrochemical cell. It is an electrochemical cell, and this electrochemical cell is of two types. We have the galvanic, which is known as the voltaic cell, we have the electrolytic cell. Before now, I introduced this particular topic, but just that we spent time only to treat how to balance redox reaction, because in an electrochemical cell, the type of reaction that takes place inside the cell is actually redox reaction. Now, but today we want to talk about first cell potential, right? In the next 30 minutes, we should be done with this, and then I'll switch back to electrolysis, because electrolysis is under electrochemical cell, whereas cell potential is under galvanic cell. So I could just say cell potential slash electrolysis. So I want to see the two common calculations that are predominant under these two types of cells. Right? Like I said, when we talk about galvanic cell or voltaic cell, we talk about cell potential. We have no business with cell potential if we're talking about electrolytic cell. Now let me explain what cell potential means. Now this cell potential can also be called cell EMF. Can also be called cell EMF. Now which also can be written as E cell. Can be written as this. So most of the times you may be asked to solve for E naught cell, right? This is cell potential. It's also called cell EMF. Now remember I told us that these two types of cell, galvanic cell is a type of cell whereby spontaneous chemical reaction taking place inside the cell give rise to electric current. That electric current that is being given out to is actually called the voltage. That is why your cell, your battery, right? Your battery you have, your finger battery, your cell phone batteries, all those guys are considered galvanic cell because those batteries actually undergoes reaction inside of them to produce voltage or to produce power that powers whatever that battery is connected to. On the other hand, electrolytic cell utilizes electric current. So this guy does not produce current. This guy does not produce voltage. Instead, current is added to this guy to carry out series of actions such as electrolysis. Whereas in this case, a reaction inside the cell reacts and gives rise to cell potential. Okay. So we've done the quick introduction for that. So let's head on to cell potential. Cell potential is a difference between two electrode potential. Full stop. Please continue. One of the electrodes is the cathode, while the other is the anode. One of the electrodes is the cathode, whereas the other is the anode. Full stop. Paragraph, please. Cell potential is mostly calculated for galvanic cells. Cell potential is mostly calculated for galvanic cells. Just like I told us earlier that we don't calculate cell potential for electrolytic cell. So we said cell potential is mostly calculated for galvanic cell. Not, please, what was the word I used before? Is it mostly? What did I use before? Please, I think you just remove that mostly. Just cell potential is calculated for galvanic cell. Just move that mostly. It is calculated for galvanic. Cell notation / representation. Cell notation slash representation is a shorthand description of a voltaic slash galvanic cell. A shorthand description of a voltaic slash galvanic cell. Now, what it simply means is that, let me show something. Let me give us an example. Consider the reaction. We have now look at this. This reaction is a cell reaction. Remember, anytime you're being told that a reaction is a cell reaction, it's what we call cell reaction. It's what we call half cell. A cell, a complete cell, is made up of two electrodes, the anode and the cathode. So the reaction that takes place in both the anode and the cathode is a complete reaction, which is known as cell reaction. However, if a reaction should take place in just one of them, or the reaction that takes place in one of the electrodes, is called half cell, right? And cathode actually sees reduction reaction, while anode undergoes oxidation. We are going to talk about that much later when we start our calculation. Now look at this. Now this is considered a cell. Now this is how a cell looks like. Let's have the first part, and let's have the second part. I want the electrodes to be on two different containers. Now this is the first one, okay? This is the first guy. We have this. Now, this guy looks like. So we have this guy, let's say, this is the cathode, and this is the anode. And we just said that cathode is positive, anode is what? Negative. Now this is the electrolyte, and this are the electrolytes. Class, this stuff here, this empty pipe here, is what we call a salt bridge. Now, salt bridge is not present in electrolytic cell. However, it is present in galvanic cell. So that this also another difference between what is actually differentiating galvanic and electrolytic cell. Now, please look at this. Most of the time, I can actually write this same structure, what you're seeing here, in a shorthand form, which is actually what we are talking about here. Instead of you to draw this bulky stuff like this, I can decide to shorten it, and they can use it to ask you questions in exams. So this stuff you're seeing here, I'm going to shorten this guy, and then give us a shorthand form of this entire cell. Remember, every cell, galvanic cell, must have number one, electrode, which is anode and what? Cathode. Number two is what, class? Salt bridge. Now these two things must be present for any cell to act as a galvanic cell. But most of the times, they will not give you this structure. So how we are going to take this guy and put it in a shorthand form. I need to clean this so that we can write this guy effectively. Remember, cell notation is a shorthand form of writing this whole stuff you're seeing here. So instead of them to write this big stuff for you in a question paper, they'll just use a cell notation pattern. So how does it look like? So we have, please, for this reaction above, the cell notation is as follows. We have the first one. Now this is how it looks like. Please, in cell notation, the left-hand side, is always the anode, while the right-hand side is always the cathode. Like I said, I actually skipped some introductory parts based on the fact that I don't want to start defining and wasting our time. But once we are done with the calculation part, I'm still going to quickly give us an overview of that. So here, now let's explain this stuff. Please finish writing this so I can explain. Let's go. Based on the structure I just gave us earlier, we saw the anode, one of the electrodes, we saw the cathode. Now it's very important for us to know this class, that whether a cell is an electrolytic cell or whether a cell is a galvanic cell, the reaction that takes place at the anode is always oxidation. It is constant. Whether it is of galvanic cell or electrolytic cell, anode, reaction that takes place at the anode is oxidation. Cathode is what? Reduction. Now, how can we interpret this guy? Please put down. The left-hand side of a cell notation is always the anode. It is a cell notation for a reason. If you go and take what is supposed to be at the left-hand side and put at the right-hand side, you fail the question. The left-hand side of a cell notation is always the anode. Whereas the right-hand side is what? The cathode. Class, this line here, you're seeing here, please, you have to note this down. The line here is the boundary between the electrodes and the electrolyte, because you're going to dip the electrode inside a solution. So the boundary between the electrodes and the electrolyte is this single line here. Right? Now, the two double stroke. Now this guy is the boundary or the interface. Whereas this guy is what we call the what? The salt bridge. Please, this two double line at the center, just in case you're being asked, the two double line at the center of a cell notation is that. The answer is what? Salt bridge. Okay, so this is actually how a cell notation looks like. The left-hand side of a cell notation is the anode, which depicts the oxidation. The right-hand side is a cathode, which depicts the reduction. Now, what are the various ways question can be asked under this guide? Number one, the single line separating the metal in a solid form and its aqueous form in a cell notation. This is a metal, solid. This is a metal in an aqueous form. That single line is what we call the boundary. The double line is what we call the what? Salt bridge. Class, what is the function of a salt bridge? What is the function of a salt bridge? To stabilize the what? To separate the. What is the function of? Because there must be a reason why that guy is there. Let me give you an example. Have you seen waterfall before? Maybe you see something that there is a water at the bottom and water is pulling out of a pipe and falling back. Is it not so? Do you know that if that water is actually not falling back into that container, right? If the water keep pouring out and keep wasting, in less time that water will stop running. I don't even understand what I'm trying to say. It's more like a continuous process. You go up, come down, enter the container back. Is it not so? Go up, come down. But in as much as that stuff is going up, some of them are evaporating because it's water. But imagine that water that is going up is not coming back to enter that container. What will happen? It will finish faster back. Now look at this. salt bridge, the same thing is happening. Remember, in a cell, reduction takes place at the cathode, isn't also? Oxidation takes place at the what? In other words, in a redox reaction, there is what we call flow of electrons. Flow of what? When something oxidizes, it loses electrons, isn't also? And when it loses electron, the young man that is reducing does what? Gain the electron. What now happens if the person that is donating the electrons stop donating the electrons? Everything will stop, huh? Yes. But the work of the salt bridge is that it helps to maintain electron flow for a very long time. As this guy is pulling electron to this guy via the wire, because that is where the current is taking place, right? The salt bridge is pulling the electrons back and returning it back to this guy. I don't know if you understand my point. I'm giving us a layman understanding. Later I'm going to define what a salt bridge does. I have a cell. It's not necessary. Let's write. All this is not necessary. Please put down. A salt bridge helps to maintain electrical neutrality. A salt bridge helps to maintain electrical neutrality. It helps to maintain electrical neutrality between the two cells. It helps to maintain electrical neutrality between the two cells. So that is actually the major function of salt bridge. Also, salt bridge is always made up of a salt. Usually potassium chloride. Salt bridge is usually made up of a salt, usually potassium chloride salt. Please do that. Given the following cell notation, we have A. Give the half cell reaction. B. Give overall cell reaction. Now remember, I told us that the first part of question that they can ask us is to ask us the meaning of all these lines here. The two double stroke, the single stroke stands for what? The boundary, the salt bridge. Of course, salt bridge is made up of a salt, right? Mostly potassium chloride. And the main work of a salt bridge is to maintain electrical neutrality between both of them. Okay. Now, so you're being given this in exams, right? So we are asked to give the half reaction for this. Remember, we have two half reactions. So I'll say solution. Plus, we have two half reactions. We have the reduction half cell reaction, which is the reaction that is always occurring at the cathode. And then we have B, the oxidation half cell reaction. Reaction that is always occurring at the anode. Now, please go. So the first one, let's do the reduction, and oxidation. It's not a must that you write reduction first, just that preferably I like starting with reduction, since if I start this guy, it does give me redox. If I start with oxidation, it doesn't really matter. Class, look at this half reaction, this cell potential, and this cell notation. We want to get the reduction reaction. Which side of a cell notation is always the reduction side? The right or the left? Right. Now, for us to actually ascertain that, the right hand side is always the cathode or the anode. Cathode, right? Is it cathode or anode? Cathode. Some persons are saying anode. No. It's cathode, right? Yes. So cathode, we see the reduction. And not just that, look at this. Look at this guy very well, a very short cut. Oxidation number of copper 2. This guy is copper 2, right? Yes. When I taught us oxidation number, I said oxidation state of a monoatomic ion is a charge, is it not so? Yes. The charge of this guy is what? Plus 2. Yes. And this guy is what? 0. So you notice that what is written first is plus 2. And this guy is what? 0. So there is a reduction, is it not so? Yes. But most of the times, it's not always like that. And this is just one of the methods. So I'll come here, I'll say reduction, I'll put this first, aqueous, and I'll put this solid. I'll come to the second side. If you do the same thing, the second side is going to be anode, which is oxidation, right? Yes. Oxidation of this guy, 3 elements that is uncombined, this is 0, is it not so? And this guy is how many? 0 to 2, there is an increase, you know so? So I'll say zinc to what? Zinc to plus. But we are not done. You have to balance this guy in terms of atoms and also in terms of charge. In terms of atom, this guy is balanced already. Copper is 1, copper is also 1, right? If you look at the charge, this guy, the left hand side is having what? Plus 2. The right hand side is having what? 0. Please, if you want to balance this guy, this is what you're going to do. The side that is actually more positive, you add electrons. Listen. The side that is more positive, you do what? Your sole aim is to make sure that the one that is more positive is brought down, right? To be the same as the one that is what? Less positive. Between 2 and 0, which of this is more positive or which of this is higher? 2, right? Meaning that I need to reduce 2 to what? 0. How many electrons will I add to this guy? 2 electrons, right? Because electrons are negatively what? Charged. So I'll come to the left hand side, I'll say what? Plus 2. This guy is balanced in terms of charge and in terms of atoms. I'll come to the second guy. The right hand side has a charge of what? Plus 2. And the left hand side has a charge of what? 0. Now, which of the sides is more positive, the right or the left? Right. Of course, this guy is plus 3, isn't also? Let's examine it. So, my aim is to make sure that this guy that is plus 2 is reduced to be the same thing as the one that is 0, isn't also? So, where will I add the electron? Is it on the left hand side or on the right hand side? Right. Please don't mistake this. Check out for the side that is more positive. Our aim is always to reduce the higher one to the what? Lower. This one is 0, so there's nothing to reduce here again. So you come here. And this particular stuff is applicable to life. In life, you see, when somebody is broke, you can't go below being broke. You're broke. It's not so. But when you have money, you can be reduced to what? You see that's how life is. So I think chemistry is following every aspect of life. So you have to break. All right. Pass. This is the first answer to that guy. This is the first solution. They asked us They asked us to give the half cell reaction. So we've given the half cell reaction. The reduction half cell, this one is taking place at the cathode, which is the right hand side. Let's now the left hand side is the anode, which is where oxidation will take place, and the right hand side is the cathode, which is where reduction will take place. So we are done with the first question. The next question says, give the overall reaction. So the second guy is actually very simple. How do I mean? Overall reaction, we say B, overall cell reaction is always what we refer to as redox reaction. And redox reaction, you can see red already there, and you can see ox. So for me to form redox reaction, I'll simply combine two of them together. So if I want to combine two of them together, Clara, listen. Before you combine these two guys together, look at the electrons. If they are not the same, you cannot add it together. It's a must. So for me to bring these two together, electron on the left hand side is 2. Electron on the right hand side is how many? Are they the same? In that case, they can go together. If they are not the same, you have to make it to be the same. What do I mean? As in this place now was 3. Here is 3, and here is 2. They are not together, so you cannot combine this reaction like this. If you combine this reaction, you fail the question. For you to combine the reaction, electron on the left-hand side must always be the same as one on the what? So for you to do that, this is 2 and this is 3. So the best action would be, what will I multiply with 2? Please just do inverse multiplication. Take these 3 and multiply with 2. And take this 2 and multiply with what? So that they will give us a whole number, which is what? 6. Now we only did this because there is no whole number that can be multiplied with 2 to give me what? 3. That is why I'm doing this. What if I have something like this? I have something like 6 here. I'm not going to do inverse multiplication. Because you ask yourself, between 2 and 6, which of these is the smallest? 2, right? What can I multiply with 2 to give me 6? Whole number. It's possible, right? You now say multiply this guy by 3, and this one remains the same. But if here were to be 3, you ask yourself, there is no whole number that you can multiply with 2 to give you what? 3. So in that case, you do what I call inverse multiplication. This one to 3, and this one to what? 2. So that will give me what? 6. Okay. But in this question, we are not going to do any multiplication because the 2 electrons are all the same. So I'm going to combine both of them together so that this guy, so let's write it out. When you combine, we have our red and our ox. So we have C plus, we have this cancels this. So when you bring down this, you now have C2 plus. It does not matter if this one can be written first. It doesn't matter. So before you start calling my attention and say, why not put it like this? Class. So let's look at this. When two have cells and their standard electrode potential, please, this note you're seeing here stands for standard, please. Right, very, very important. This stuff stands for standard. When two have cells and their standard electrode potentials are given. When two have cells and their standard electrode potentials are given, in order to construct a galvanic cell, or in order to calculate cell potential, are given in order to construct a galvanic cell, or in order to calculate the cell potential, comma, they have cell that is more positive. They have cell that is more positive, in brackets, larger electrode potential. They have cell that is more positive, in brackets, larger electrode potential value, will act as the cathode. Will act as the cathode, in brackets, reduction half cell, will act as the cathode, in brackets, reduction half cell, while the other with a smaller electrode potential. While the other with a smaller electrode potential will act as the anode. While the other with a smaller electrode potential will act as the anode, in brackets, oxidation half cell. Please do down. What is a cell potential? What is a cell potential of an electrochemical cell? What is the cell potential of an electrochemical cell comprising of the two half cells below? Comprising of the two half cells below. Alright, please look up. I say, whenever two reduction potential, class, they will always give it to you guys in terms of reduction. Reduction simply means the two electrons will always be on the same side. If you notice, they did not indicate which one is reduction, they did not indicate which one is oxidation. Is it not so? You're the one to actually identify which of these two would be the reduction and which of them would be the oxidation. So they will always give it to us in this format. The two of them will always have electrons on the same side. Take note of that. So this stuff is what we call the reduction potential. Reduction potential is what we have here. And of course, the meaning of potential means something that has a tendency to occur. So the greater the reduction potential, the greater is that guy is going to reduce, and the other guy will go as the oxidation. So now look up. Let's solve this guy. I just gave us a note. I said anytime two half cells and their potentials are given to us, the one that has a larger potential value, reduction potential, remains a cathode, which is reduction. while the other one with a smaller value becomes a what? Anode. Now look up. Between these two, let me tell us something. For two positive values, the one with the highest magnitude is the biggest. Are you following me? Yes. For two negative values, the one with a smaller magnitude will be the what? Yes. So that you don't come and ask me, but why is it, but this one is bigger? Please, let's be guided. Minus, minus, the smaller one becomes the biggest. Plus, plus, the bigger one remains the biggest. You understand? Yeah. So between these two guys, which of them is the biggest? The first one or the second guy? The first one. Please, this is the biggest. Because this is up here, both of them they are negative. So in negative, the smaller value is always the biggest. So I'll come here. Remember, the larger value will remain as the cathode. So this is what I'm going to do. Cathode, which is where reduction is going to take place. This remains like that. We have Sn 2 plus 2A giving us Sn. Now this time around, I'm going to now add cathode here. This becomes minus 0.36 volts. Once you've identified the one that is the smallest, the other one becomes what? Anode, automatically. So this we have the anode. Please, in the anode, once you've identified the one that is the cathode, the other guy you must reverse it. You must do what? It's a must. You must reverse the other guy. It's a must. So this becomes zinc 2 plus 2 electron. Now this is now what? Please, when you reverse this guy, you don't change this sign too. Yeah, don't change it. So we have minus 0.763 volts. Now, assuming this question they gave us as OBJ. Listen, assuming it is as OBJ. I don't even need to do all of this. I'll just use my formula directly from here. But once it is theory or subjective, please always show this working. It's a must. Most of the times, they will give you something that the electrons will not be the same. Right? But let's finish this guy first, then I'll talk about that. So the full reaction will be, class, for us to get the overall reaction, we have to cancel out the electrons. Is it also? Yes. And for us to cancel out the electrons, they must be the same. This is 2, and this is what? 2. Can it go? Yes. But what if in the case where it was not 2? I already told us what to do, right? Yes. If this guy is 2 and this guy is 3, do inverse multiplication. But when you do that, it has no business with this. This value is not going to change. If you like multiply this guy by 1 million, it has no business with this. Because cell potential is an intensive property. It's a what? Intensive property. Do you know what is intensive property? What's the meaning? They don't depend on the amount. Take note of that. So you cancel this guy. So this becomes Sn 2 plus. Please, like I said, it's not a must. I always like starting with reduction. Yeah, that is, if you check all my classes, reduction is always written first. But if you check their notes, they always give oxidation first because this zinc is supposed to come before this guy. So I can equally do it as well. We have zinc plus Sn 2 plus, giving me because anytime something is actually having a charge, 2 minus is always an aqueous. Anytime a metal, let me use metal. Anytime metal has a charge, it's always an aqueous. Same as non-metals. If a metal does not have a charge, it must be solid. Non-metal, some of them will always give rise to gas, and the rest of them. Just take note of that. In case you're wondering why I'm adding aqueous here. This means that this guy is now in solution. Are we done with this stuff? If you stop here, you will not get 1 mark. I say 1, you will not get. They did not ask you for the cell reaction. What they ask is for what? What they ask you for what? Cell potential. This one is just to spice up what I did here. Take note of that. If you stop here, you will not get 1 mark. Or they might even help you and give you 0.5. So always stick to the question. Please write. Let's solve cell potential. Now recall that our E cell is always E what? Cathode minus what? Now what is our E cathode here? Minus 0.13 what? 6. And what is our E anode? Minus becomes what? Please press your calculator for me, everything here. Press your calculator for me. Plus or minus? 0.6274. Is that the answer? In exams, if you don't have enough space, you can come down here and write it and solve it under here. So I just had to solve it here at once. So please, this is what they asked me for. This one I just gave us this to actually show us that you cannot get to that without passing through this stage. So I don't really have to solve. I will only solve one more question on this. Then I'll actually move to the next stuff. I believe that anytime they give you questions pertaining to this, as long as the electrons are the same, you have no problem. The only place you may have issues is if these electrons are not the same. Right? And the only issue you're going to have is if that question is theory. If that question is not theory, just bring your calculator. This is what you're going to do. Assuming this question is OBJ, right? And I'm not supposed to show it. I'll just say, between these two values, which of them is the largest? The first one back. So I'll say the cathode is minus 0.136. Once I've identified the first one, the other one must be the anode. There's no two ways about it. So I'll now say anode equals to minus 0.763. All these things I'm doing, I'm not even going to write this stuff out. If it is an OPG, I'll just come here and say cathode and do what? Anode. I'll now say, oh, the formula here is always cathode minus what? So I'll say my cathode is minus 0.136. Please don't always forget this guy. That is minus 0.1. Minus is what? So if you do your answer, it's going to give you the same thing here. So this stuff here is only if the question is theory or subjective that has space. If it is subjective and it's only one line, if they don't expect you to do magic, just give them this. Listen to what I'm telling you. If it is subjective and it's only one line that is given to you, you don't need all of this. You don't need it. What you just need to do is tell them which one is a cathode. If I label it because they already know. E cell equals to E cathode minus what? Put the values, and give them the answer. You only go to this on the condition that the question is what? Theory. I am now. Some persons, this is what I'm saying now. Somebody here is not, he entered here and came out from here. In exams, you go and do this thing and realize that there's no space again. There's no extra sheet here. Now we have use of spontaneity. Use of cell potential to predict spontaneity of, or in a cell, in a galvanic cell, whatever it is. Now in thermodynamics, or because this topic can also find application in thermodynamics. When we talk about spontaneity, okay, let's please put down spontaneous processes. Spontaneous processes are processes that have the potential or tendency to occur on its own without the aid of an external force. They have the potential or the tendency to occur on its own without the aid of an external force. Alright. Full stop. All natural processes are spontaneous processes. All natural processes are spontaneous processes. So you can think, you can just want to think about any natural process you know. All natural processes are spontaneous processes. Now, remember I told us that in an electrochemical cell, we have two types of cell. Take note of, listen to what I'm about to tell you now. The reactions that take place inside a galvanic cell is a spontaneous reaction. In other words, you can actually redefine a galvanic cell as a cell that utilizes spontaneous chemical reaction inside to produce electric current. So if the reaction inside a cell is not spontaneous, that cell is not galvanic. So that is actually why I want to see how we can use cell potential to predict spontaneity in a galvanic cell. And most of the times, the questions will be asked in this format. Listen very carefully. Can a galvanic cell be constructed? Can a galvanic cell be what? Constructed. Now, anytime you see those kind of questions, you don't have to panic. They don't expect you to carry shovel and machete and be constructing it. All you just need to do, solve for your cell potential. If the answer is positive, if the answer of cell potential is positive, it means that the reaction inside the cell is spontaneous. It means that what? Reaction inside the cell is what? And once the reaction inside the cell is spontaneous, yes, you can actually construct a galvanic cell with that cell potential. But if after carrying out your calculation, and this guy is giving you what? Minus. It means that the reaction inside the galvanic cell, inside the cell, is not spontaneous, right? So that stuff cannot form a galvanic what? Cell. Because a galvanic cell must have a spontaneous reaction taking place inside of it. So let's put down. Please write. Cell potential can be used to predict if the reaction inside a cell is spontaneous, that's in brackets, that is galvanic cell, or if a galvanic cell can be constructed. I repeat, cell potential can be used to predict if a spontaneous reaction did what, please? What did I say the first time? Yeah, can be used to predict if the reaction inside the cell is spontaneous, that is galvanic cell, or if a galvanic cell can be constructed. A. If E cell is positive, that is greater than 0. Hey, are you guys aware that my camera is here? Eh? You know that this stuff is speaking that stuff. Be careful. If the cell potential is positive, that is greater than 0, the reaction is spontaneous. And in this case, a galvanic cell can be constructed. Remember, I said most of the time they like using the word construct so that they throw you off balance, right? They are not expecting you to go and start molding blocks. See, it means, once they give you the two reactions, they'll give you the half cell, because if they give you the half cell, that's what you're going to use to construct the cell. This one will be on the anode, this one will be at the cathode. Once you have your cathode and the anode, you're good to go. You can couple it and form a cell. But before you proceed with the coupling, you need to solve for the cell potential. If the answer is giving you anything greater than 0, which means it's positive, it means that the reaction inside the cell will be spontaneous. So therefore, a galvanic cell can be produced in that case. B, if E naught cell is negative, now, if the reaction is not spontaneous, if you solve for your cell potential and it's negative, that is less than 0, it means that the reaction is not spontaneous. If something is not spontaneous, it can be called non-spontaneous. But the reverse of that reaction will be spontaneous.